Good evening, children. Today I are going to discuss types of salts and salt hydrolysis. So the types of hydrolysis, there are different kind of salts are there. That is different kinds of salts. That is types of salts. First one is normal salts. Normal salts. So what normal salts, children? When our acid base combines together to form the salts. You know, neutralization. What is meant by neutralization? Acid combines with the base to form salt and water. That is called neutralization process. In this neutralization process, to form one of the product salt, that is called normal salt or else simple salt. Say examples, you can take acid CH3COOH plus NaOH combines to form the salt. Your formation of the salt is CH3COONa plus water. Acid, this is base. Combines together form the salt and water. This is normal salt. Or else one more example, HCl plus NaOH to form the salt NaCl plus water. These are normal salts or simple salts example. Second type of salts are acidic salts. Acidic salts. Acidic salts means replaceable of hydrogen atom from the salts are acidic salts. What are acidic salts? Replaceable of hydrogen from salt. Replaceable of hydrogen from salt are acidic salts. See children, example, if I am taking NaHSO4. NaHSO4. It is an acidic salt because this hydrogen atom can be replaceable. Then what happened? Replaceable of this hydrogen atom can get the product is Na2SO4 plus H plus also coming. So that's why here NaHSO4 is acidic salt. Like KHSO4 acidic salt. Next, what are acidic salts? Replaceable of hydrogen from salt. NaHSO4 is a salt, replaceable of hydrogen to get Na2SO4 and H plus. This is acidic nature of the salt. B. Next type of salt, children, basic salts. Basic salts. It is a salt, but basic nature. This type of salts having replaceable of hydroxyl group from the salt. Replaceable of hydroxyl group. Replaceable of hydroxyl group from salt. What, children? Replaceable of hydroxyl group from salt are basic salts. See example, children. Here magnesium hydroxychloride. Magnesium hydroxychloride. Here possible to remove of hydroxyl group. That's why this is basic salt. Next, one more example, children. Calcium hydroxychloride is also basic salt. So what are here? One is called normal salts. Normal salt is obtained by acid plus base combining. Here HCl, NaOH combining NaCl. Here any replaceable of hydrogens in this salt? Any replaceable of hydroxyl groups? No. That's why it is a completely here hydrolysis takes place here. Completely reacts here on the neutral salt. That is normal salt. Next goes to acidic salt. Here acidic salt here coming here partially reaction takes place. Acid plus base NaOH and H2SO4 but not completely. That's why your product is coming NaHSO4. This sodium hydrogen sulfate or sodium bisulfate. What is this name? Sodium hydrogen sulfate or sodium bisulfate. Dissociated into air, getting completely Na2SO4 and H plus. It behaves as acidic salts like KHSO4. It is also again hydrogen atom is there. Here also hydrogen atom is there. These hydrogens are replaceable. That's why these are acidic salts. Like basic salts, children. Basic salts means replaceable of hydroxyl group from salt. So examples here, it is a salt. Again here replaceable of hydroxyl group. That's why it is behavior is of basic nature, but it is salt also. That is called basic salt. Examples here, magnesium hydroxychloride as well as calcium hydroxychloride. Here A, B, C. Three types are there. Still, here I am writing another type of salts. Okay, children. Next type of salt is a double salt. Double salt. Double means two salts combining. So example of here two salts combining. One is a K2SO4, potassium sulfate, and one more is a aluminum sulfate, Al2SO4 trichloride. 24H2O. It having containing always hydrated substance. See children, the potassium sulfate, one salt, aluminum sulfate, another salt, two salts are present. It is example of double salts. Like one more type children, here mixed salts. So mixed salts means here which contains two cations or anions. Which contains two cations or anions. See children, example here. One of the example, calcium oxychloride. Calcium oxychloride. It is also bleaching powder, calcium oxychloride, which contains calcium plus 2 ion and two anions are there. One is a oxychloride ion and one more is a Cl minus ion. So this salt containing one cation, two anions, or else one anion, two cations also present. Example here, Na, K and SO4. NaKSO4, sodium potassium sulfate, which contains Na plus, K plus and SO4 minus 2. So mixed salts. Okay children, what is double salt? Which contains two salts. Which contains two salts, double salts. Mixed salt, which contains either two cations or two anions with here one of the ion. So that's why here one cation, here two anions are present. In this case, two cations, one anion is present. That's why either two cations or anions with one of the ion, opposite ion. That is mixed salt. One more type of salt children, complex salts. Complex salts. So which contains complex ion. Complex salts means complex ion is present. So here complex ion formula example see K4FeCN6. This is complex salt. This is called complex ion. This is complex ion. So complex part always show in the square brackets. Outside of ion is there. This is called counter ion. So complex compound. It containing complex ion as well as counter ion. These together are complex salts. So these are the different types of salts, children. So how many types are there here? So here total 5 types of salts are there. First is called normal salts. Second one is called acidic salt. Third one is called basic salts. Fourth one is called mixed salts, and double salts, complex salts. Here total different types of salts. Okay, children. So now we are going to discuss types of salts. About one more is about salt hydrolysis. The main concept is about salt hydrolysis. So what is meant by salt hydrolysis? So salt hydrolysis. So now we are going to salt hydrolysis. What meaning here? Salt hydrolysis. Okay, children. Now goes to discuss salt hydrolysis. So what is salt hydrolysis? The first point, salt hydrolysis is a reverse phenomenon of neutralization. What is this? Reverse phenomenon of neutralization. Neutralization. So you know, children, what is neutralization? Here acid plus base combines together to form salt and water. So here salt plus water is formed. This is called neutralization process. So but here reverse phenomena. Reverse phenomena means, yes, what happened? Salt here undergoes hydrolysis to form acid plus base compound form. So this is called salt hydrolysis, or else hydrolysis of salt. Hydrolysis of salt or salt hydrolysis. So this is neutralization process. Now it is a reverse. That's why it is a salt hydrolysis is called a reverse phenomenon of neutralization. So that's why, yeah, how to define? So yeah, what is the definition of salt hydrolysis or hydrolysis of salts? So yeah, hydrolysis of salts means either cation or anion or both the ions reacts with water to form acidic solution or basic solution or both. It's called the salt hydrolysis. Once again, children, yeah, what is salt hydrolysis? Either cation or anion or both the ions reacts with water to form acidic solution or basic solution or even neutral solution. That is called the hydrolysis of salts. See your example, children. Hydrolysis of cation. I am taking A plus cation, general formula cation. Hydrolysis here H2O. Then what happens, children, here? Hydrolysis of cation to get here A plus, you combines with the opposite charge of an OH. You are producing H plus ion. So whenever cation here hydrolysis, cation undergoes hydrolysis. What happened here? Producing of H plus ions. Producing of H plus ions means, so what is the nature of solution? Acidic nature of solution. Like anion. Here anion undergoes hydrolysis. I am taking B minus. It is anion. Undergoes hydrolysis or reacts with water. Anion undergoes hydrolysis to form the product here B minus attracted by opposite charge of ions BH plus. That's why B minus to H plus becomes neutral. Remaining what is there? OH minus ions produces. You know, according to Arrhenius theory, what happened? Yeah, the substance producing of H plus ions in aqueous solution is called acidic nature. Producing of OH minus ions in aqueous solution is called basic nature. That's why according to Arrhenius theory here, cation undergoes hydrolysis, H plus ions produces. That's why this solution is acidic nature. Anion undergoes hydrolysis, produces OH minus ions. This nature of this solution is basic nature solution. If in case of both ions undergoes hydrolysis, A plus and B minus undergoes hydrolysis to form here AHBOH. Nothing but what happened? It is a acid formation. It is a base formation. Acid and base means nothing but here nature of the solution is nearly neutral solution. So that is why what is the definition of salt hydrolysis or hydrolysis of salts? So here salt hydrolysis or hydrolysis of salts is a chemical process. Nothing but here ions reacts with water or formation of here acidic solution or basic solution or even neutral solution. That's why hydrolysis of salt is called either cation or anion or both the ions undergoes hydrolysis to produces acidic solution or basic solution or even neutral solution is called the salt hydrolysis or else hydrolysis of salt. Is it clear, children? So now again these salt hydrolysis are again classified into 4 types of hydrolysis of salts. So now what, children? Salt hydrolysis are again classified into here 4 types of salts hydrolysis. Yeah. Type of salt hydrolysis. Type of salt hydrolysis, children. Type of salt hydrolysis. Here one is salts of strong acid plus strong base. Salts of strong acid and strong base. This is one of the type of salts. You see, children. Salts of strong acid and strong base. Salt. How you obtain salt? By the combination of strong acid and strong base. See example here. What salt here I am taking? So, strong acid. Example I am taking HCl. Strong base I am taking NaOH. These two are together combining what type of salt formed here? NaCl plus H2O. This is a sodium chloride formation. It is a NaCl is a salt of strong acid. This is strong acid. It is a strong base combined to get the sodium chloride salt. It is a salts of strong acid and strong base. But a formation of NaCl is dissolved into the water. What happened? Combining up here form the Na plus ion aqueous solution and Cl minus aqueous solution. That's why your salt is by combining of strong acid and strong base. Here this salt is further does not undergoes reaction. Only a dissolved form the Na plus and Cl minus ions. So that's why this type of salts do not undergo hydrolysis. Type of salt. This type of salts I am discussing salts of strong acid and strong base type of salt further does not undergoes hydrolysis. Does not undergoes hydrolysis. But therefore, this nature of this solution is pH. How much here? 7. Because of what is the nature of solution here? It is a neutral nature. This salt solution is a neutral nature. NaCl and H2O. NaCl what happened? Dissociated into Na plus and Cl minus ions in aqueous solution. So this salt obtained by combining of strong acid and strong base. That's why here strong acid and strong base salt further does not undergoes hydrolysis. Therefore always the pH is equal to 7 for this type of salts. Its nature is a neutral nature. So example here children, NaCl or like that. One more example for NaCl. One more example, Na2SO4 also. It is also a salt of, what is coming? Salt of NaOH and H2SO4 children. It is a strong base, strong acid. Like that. Yeah, one more example, NaNO3. NaNO3. It is also NaOH plus HNO3 like KNO3. So like that, these are all are salts of strong acid and strong base like NaCl salts, Na2SO4 salt, NaNO3 salts, KNO3. These all are salts are obtained by combining of strong acid and strong base. That's why these salts are further does not undergo hydrolysis. That's why the nature of the solution is always neutral. Therefore, the pH should be how much? 7 children. Is it clear? This is salts of strong acid and strong base. So this type of salts always the pH is how much children? This type of salts pH is equal to 7 only. Next children. Next type of salts. Next, second type of salts I am taking children. Second type of salts. What second type of salts here? Second type of salts. Here, examples of here. So next children, salts of weak acid and strong base. Salts of weak acid, strong base. So weak acid means example I am taking acetic acid plus strong base I am taking NaOH. So these two are combining to get the salt is CH3, COONA, sodium acetate and water. So you know, weak acid is partially undergoes hydrolysis, partially ionization. It is a weak acid, it is a strong base to get the salts. Here CH3CONA, sodium acetate. Here sodium acetate, it reacts with water. Here reacts with water. What coming here? CH3, COO minus. CH3, COO minus. Here coming again Na plus ions. Here also H plus and OH are there. So this one H plus and OH minus ions. What happened here? CH3COO minus ion undergoes hydrolysis, combining to get the CH3COOH plus producing of OH minus ions. That means what happened? Which ion undergoes here hydrolysis? This type of salts, anion undergoes hydrolysis. Due to anion undergoes hydrolysis here, get the product is acetic acid producing of OH minus ions. Therefore, this type of the salt solutions are nature is what is the nature? Basic nature, children. What is the nature? Basic nature of this solution. So, sodium acetate in aqueous solution, what is the nature? Basic nature of solution. So, due to basic nature means so, your number of H plus ions are less than OH minus ions. So, this observed here, OH minus ions are more number. But acetic acid still remains constant only, not ionized. So, that's why it is H plus ions concentration less, OH minus concentration should be more. But therefore, pH value is how much children? Yeah, pH value is greater than 7. pH value is greater than 7. Number of H plus ions are here less, OH minus ions are more. Here the nature of the solution is basic nature. When this type of solution is tested with litmus paper also. What happened litmus paper here? Due to basic nature, the red color litmus paper, here litmus paper converted to blue color converted here. Red to blue is converted. That's why It is also nature is basic nature of solution. This is about the salts of weak acid and a strong base. What is example children here? Sodium acetate is one of the best example for salts of weak acid and a strong base. Is it clear? So always the salts of weak acid and strong base, corresponding salts in aqueous solution, nature is a basic nature. And pH should be greater than 7. But what about H plus ions, OH minus ions? H plus ions are less than OH minus ions. Okay children, this is the second type of solutions. So next, but this type of solutions are over. Next goes to another type of solutions, third type of solutions. Already two types are over. Next goes to third type of solutions. See children, third type of solutions. What here? Salts of here weak base, strong acid. Weak base, strong acid. Salts of weak base and strong acid solutions. Give example children. Salts of weak base and strong base. Weak base is example here. NH4OH plus combined strong acid and taking HCl. These two are combining, what get the salt? NH4Cl salt. This is one of the example of salts of weak base and strong acid. Like another example here taken as here NH4OH plus I am taking H2SO4 strong acid. You know, to get the salt is about what salt coming? Ammonium sulfate. NH4 taken twice, SO4. Ammonium sulfate, ammonium chloride. So the example of this one, like you take aluminum hydroxide here plus I am taking H2SO4 to get the salt is aluminum sulfate, Al2SO4 taken twice. So either ammonium chloride or ammonium sulfate, aluminum sulfates are examples of salts of weak base and strong acid. So here ammonium hydroxide is a weak base. So weak bases are partially ionization, not completely ionization. So that's why, but these are ions. Which ions undergoes hydrolysis here? So now if you take NH4Cl in water, what get here? Formation of NH4 plus ion and Cl minus ion. This NH4 plus ion reacts with water. Here reacts with water. Then what get here? Formation of NH4OH. NH4 combines with OH minus ions. You are producing H plus ions. Observe children here. Formation of NH4OH and H plus ion. So H plus ions are more number is there. That's why are more number of H plus ions than OH minus ions. Then what is the nature children here? This nature is of acidic nature of the salts. But pH value what happened children? pH is less than 7. Is it clear? pH is less than 7. So these are salts of weak base and strong acid. Next, last one type of salts. Just here listen. Next about the salts of fourth type of salts. Here, what is the salts of fourth salts? Observe here. Now children, salts of weak acid plus weak base. Salts of weak acid, weak base type of examples. Here weak acid, you know what is weak acid? Acetic acid is a weak acid. What is weak base? Example, ammonium hydroxide. Okay children, these two are combining. What get the salt? CH3COONH4 plus H2. This name is called ammonium acetate. It is a salt of weak acid and weak base. You know, weak acids and weak base are partial ionization. That's why if this salt CH3CONA CH3COO, NH4 dissolved into the water. What get ions? CH3CO minus and NH4 plus. So now here these two ions are, both ions are undergoes hydrolysis. Why? Because here acetate ion is obtained from weak acid. Ammonium ion is obtained from weak base. Both ions are undergoes hydrolysis. CH3CO minus reacts with water. What happened? Here acetate ion combines with H plus, produce the product is CH3COOH and OH minus ions. So this is anion. Like cation, ammonium ion again undergoes here hydrolysis. NH4 plus combines with OH minus ions to form NH4OH plus, producing of H plus ions. See children, here both anion and cation. This type of salts what happened? Both anion and cation undergoes hydrolysis, producing of OH minus and H plus ions. So therefore again these H plus and OH minus are combining to get the water. That's why what type of this nature? Neutral nature. So it may nearly neutral nature. The neutral nature also depends upon producing of H plus and OH minus ions. If your equal number of H plus and OH minus are produces, this nature is a neutral nature. Okay, children. So that's why. And also, but this type of salts, you define the pH with respect to pK values. pKa and pKb values. But this type of solution to calculate the pH is equal, how to find out here? 7 plus 1 by 2 pKa minus pKb formula. pH is equal 7 plus 1 by 2 pKa minus pKb. pK and pKb values are to given, the experiment defined based on your values to calculate the pH. Okay children, these are the 4 types of salts. Okay. Total, how many types? 4 types of salts. Is it clear? What is the first type of salts? Salts of strong acid, strong base. Always neutral. That is pH is equal to 7. Second type of salts, salts of weak acid and weak base. So that type of salts are, nature is a basic nature. Means pH is greater than 7. Third type of salts are salts of weak base, strong acid. That type of solution pH is less than 7. Nature is acidic nature. But this type of salts are observed here. Weak acid and weak base. They are nearly neutral nature. But here pH is calculated by using the formula. pH is equal here 7 plus 1 by 2 pK minus pKb. Based on pK values to define the pH for this type of this solution. Okay children? I hope understand the class. Thank you children.